Thank you so much. So we were talking about integration of AI into our business applications and how Red Hat's AI portfolio can help get you there. Even if your development, your IT, and your business teams have limited to no knowledge of AI, today we're going to show the tools and the processes to take an application from a simple proof of concept chatbot that we have running on a local developer's computer to a full-fledged production application with MLOps. Now, as I said before, we're logged into our insurance claims dashboard here as an insurance adjuster. So although Parasol is a fictitious company, they still have their real challenges. Right now, we're dealing with a lot of these claims that are currently stuck on hold. If we actually go to the claims dashboard, as I'm doing here, you can see that we've got this backlog of claims. It takes our claim adjusters a long time to process these, to go through the different factors of car type, policies, contacts, and much more that have this significant impact on the decision-making process and speed. So if we check out one of these here, we can see that all of the different factors here have an impact on the efficiency of the claims that are processed by our adjusters. This is where the business owner went to get a proof of concept of a chatbot that could help our insurance claims adjusters speed up their process to minimize the amount of claims that are stuck on hold, as we saw before, but also to improve the customer experience. So I say we go ahead and ask this chatbot here, what are some vehicle repair recommendation ideas that we could get for this specific claim? And unfortunately, the response that we get back from the model isn't too helpful. You might have had a similar experience when you're using popular large language models online. But for this specific instance, well, this model hasn't been trained on any relevant information that can be helpful for the specific use case. Now, the good thing is that here at Parasol, and I say we at Parasol, you guys are all employees now, we have a lot of information and data relating to different past claim repair history, what resolutions has worked best, internal process knowledge. And what we're going to do today in the next few minutes is take this information, fine-tune it into a model specific for our use case, test this out in a development and a production environment. And the first step to do that is to get in touch with our development team. So I'm going to pretend to be a developer now and show you the perspective of someone on the Parasol application development team. Now, like many app developers out there, we might not have much or any experience using AI. After all, we're just an insurance organization, and AI is a trend that everyone wants to have. But for us, this isn't a problem because we can use Podman Desktop. Now, Podman Desktop is a cross-platform tool. It's awesome, and it allows our developers to streamline some of their container-based activities, the building of containers, running those, testing those, all from our local workstation. And no matter if our developers are using Windows, Mac, or Linux, they can get set up and work with Podman Desktop from their local environment. Now, in addition to that, for working with cloud-native applications, we have the ability to stand up and connect to Kubernetes environments. So for all of our inner loop activities, so the building, testing, and running of our applications, as well as testing those in Kubernetes environments, we're able to do from our local environment. Here you can see we've got the Podman AI Lab up. This is an extension for Podman Desktop, and what it includes are these sample recipes or templates that are essentially popular use cases that a lot of enterprises are using to integrate into their applications. Think about chatbots, RAG, image to text, code generation. All of these common use cases that I, as a developer who might not have much experience with AI, can start from. So the actual chatbot application you saw in the Parasol dashboard comes from this sample recipe. Here you can see we've got the source code that we were able to clone locally to start developing and iterating on. We've got all the components needed for this AI-enabled application. And of course, we've got a model running under the hood. So let's check that out here. If I go to the model catalogs, here we can see the Granite 7 billion parameter model that was open sourced in partnership with IBM Research back at Red Hat Summit. And what's unique about this, or what you should know, is that this is a general purpose large language model. So it's good at a lot of things: text summarization, key detail extraction, sentiment analysis, all of these tasks that we're used to using with AI. Now, what we can do with this is fine-tune it with our organization-specific data to make it truly useful, to be a subject matter expert, for example, when dealing with these repair claims. So before we do that, I also want to show you that I can run this locally from my machine in order to build out this application and also to fine-tune it. So what we're going to do here is run this as a service. So similar to how I could stand up a web server with Apache and use a browser to access those web pages, what we're doing here with the model is actually serving this and using its API to make requests. And this is really important for three main reasons. Firstly, I don't have to reach out to my IT team in order to get hardware resources. This is all on my laptop. This, for example, is about 4 gigabytes and could be run on most consumer laptops. Secondly, I might be dealing with proprietary or confidential information that I can't send to the cloud. Being able to do this here on my local machine gives me the confidence to use AI in an enterprise environment. And then finally, well, I don't have to worry about any cloud account charges or billing because this is all from my local machine. We have this here running as a service within a container. We can see we can access it from our local host, inference it on a CPU or a GPU. And for our development team, well, we've got this client code snippets to integrate this model into our existing or new applications to use AI. So I could take this, put it into my terminal and run it, but let's say I'm working in a specific language for my programming project. For example, that insurance dashboard that we just saw. Well, we're using Java and Quarkus. So just like that, I've got the code to be able to integrate this into my application to use a local model like the one we have here, or one that's running in the cloud. Now, I want to take you on a little bit of a different story because we have this model that we can build an application with, but the model is very generalistic. How do we specify it to our insurance organization? So here I am in VS Code, and what we've gathered here in this Markdown document is a collection of all of the different best practices, the internal claims knowledge, the policies that we have at our organization, all in one place from, say, Confluence, source pages, documents, PDFs. This is the single source of truth that we can use to train an AI model. How are we going to train the AI model? Well, I've got a great solution for you. This is an open source project called InstructLab. Now, we released this and open sourced it with IBM back at Red Hat Summit, and this is included in RHEL AI. What it allows us to do is, for example, I'm a developer. I have no experience training models. That's a scary area. I don't want to touch that. But what I can do here is use this YAML formatted document, so in plain text, I don't have to be a data scientist, to essentially set up a question and answer pair of how I want the model to behave. So for example, I can give it these types of scenarios to model the LLM's behavior and its intuition and fine tune it with our organization's data just using this YAML file. So let's go ahead and kick it off. I'll first make sure that the data is formatted properly. And now what we're going to do is use this C data to generate many, many more examples, tens, hundreds, or thousands of more examples of this initial training data. You can see this happening here in the terminal. And what's happening is we've connected to a RHEL AI instance. It's got increased compute power, NVIDIA H100 GPUs. I could do this from my local machine, but it would probably sound like a jet engine with the fan running at 100%. So we're doing this by connecting to our RHEL AI instance, and what we've done is the magic part of RHEL AI. We've generated synthetic training data, which is already annotated. So I, as a non-developer or a non-data scientist, could do this and contribute to the development of a large language model. So we've got that synthetic data generated. Now it's time to bake that into the model. So what we'll do is SSH into our RHEL AI instance with its hardware acceleration, its increased compute power, and we'll do a training process. Now, if you want to know the specifics, this is called parameter-efficient fine-tuning, where we take a large language foundation model and update a subset of its parameters. So, for example, to know about our insurance organization. And just like that, well, we've speeded it up a little bit for some cooking show magic, but we have this new model that we can go ahead and serve and test out with our new application. So this is RHEL AI. There's a lot of other really cool components, such as indemnification, that we'll talk about in our lab afterwards. But I want to show you that we've got our chatbot here running in Podman Desktop, and we're going to use the Kubernetes extension and capabilities to be able to push our application up to an Openshift cluster. As you saw at the top, we've got generated Kubernetes YAML that I, as a developer, don't have to create. We're also creating Openshift routes so we can test this out. And the whole time that I have gone through this process to build out the AI-enabled chatbot and fine-tune the model, I haven't had to leave Podman Desktop or VS Code. And that's really powerful because I, as a developer, could stay in my flow state and get all of this done without having to do much context switching. Let's go ahead and test out this new development version by going to the Openshift console. This is Openshift on AWS, also known as Rosa. And let's check out the front end, the route for this application, and see what's new. Great. Our development team here has added a new capability. You see that button there, the Get Recommendations with AI. Thanks, developers. And behind that is the capabilities of that new fine-tuned model. So let's go ahead and ask for some recommendations. Now, again, we're in the perspective of a claims adjuster. We need help and could be assisted through this AI model to speed up the claim process. So we'll ask it for some recommendations that it could provide and give it a second. And sweet, what we've done is taken that open source foundation model, fine-tuned it with some organizational specific data using RHEL AI, and now we have specific and customized recommendations for this model that I can go ahead and populate into the dashboard. And myself, as an insurance claim adjuster, could edit these or approve these. And it's made my life as the claim adjuster much easier. So we'll go ahead and say thank you to the model. And so we've seen now Podman Desktop in order to streamline some of these application development for the chatbot. We've also seen the model fine-tuning with RHEL AI. But now we want to see this in a production environment. This is our development cluster. How do we take this and be able to scale it up based on demand or to free up resources? Or for that model itself, how do we roll back or roll forward with the model versioning? And that's what's done with something called MLOps, or machine learning operations. This is the final part of our demo. This is Openshift AI. And this is a one-stop shop place for me to manage the life cycle of my model. So we've got places for our data scientists to run experiments, the ability to work with cluster storage or S3 buckets with data connections. We have pipelines for automating some of these processes and the ability to serve different types of AI models. I want to show you the pipelines here because what we did earlier was we ran those commands in the terminal and we did that manually. What if we want to automate this process? Well, we can do this with these pipelines to be able to gather new information about our organization, about what we need to do, but also feedback from the insurance agents, put that together, and continually build out new versions of this AI model to continually update our application in real time. So this could be event-driven or one-off like we have here. And what you'll notice here is that this is Openshift. So this is a platform that our admins are already familiar with working with. And because this is a production application, let's see a little bit behind the covers. Here is the metrics. And as I'm running these pipelines, as I'm using GPU resources, I, as an administrator, need to understand, well, what GPU, CPU resources are being utilized, and understand what's happening at any given point in time, and we can do that. But the final step, now that we've ran that pipeline for the model, let's put it into production by going to the model serving. Now, here you can see that we have not only generative AI models with LLMs, but we have predictive AI. For example, the claim estimator, or image to text with the crash damage image analysis. What we're going to add is that fine-tuned model to help out our insurance agents. So we're going to deploy it. We're going to use a runtime that's known as VLLM. It's production ready. Here we can also select a framework. We'll also define the resources we want to give to our model. We can use GPU acceleration. And the final step is just to point to where the model is located. It's that easy. So just as the developers have had their world of DevOps, our ML engineers also have their world of MLOps. And we're able to take this model, to scale it up and run it on distributed compute. So let's fast forward a little bit to the future. And this is the dashboard. As you can see, I'm logged in as an insurance claim adjuster. The number of claims that we have on hold has been greatly decreased by the effect of our new AI-enabled application, the chatbot that can provide those personalized recommendations for repairs. Now, what we've seen here today has been going from a simple AI-enabled chatbot proof of concept that wasn't very helpful to using Podman Desktop to iterate on that application, the ability of RHEL AI to generate more synthetic data and fine-tune that LLM for our use case, and Openshift AI to deploy and monitor that application. And I think it's great that the claim adjusters, the developers, and the ML engineers are all able to collaborate on this one singular goal. Now, it's great for the insurance organization because they're able to leverage AI for their use case. They're able to streamline these claims, but also to benefit from this efficiency. And in the end, the customers have a better experience. At the end, Parasol has benefited from AI and now has a competitive edge in their industry. So thank you for watching this demo, and have a great rest of the summit.